All right, folks. So this is going to be a quick video looking at how to deal with those weird slope values and why we were getting those when we were doing the landscape or the slope. And so here we are. If we go over to QGIS, so I've got my DEM loaded, and do notice down here that these coordinates are in latitude and longitude, right? So this is a geographic. This is a non-projected geographic coordinate reference system that we're dealing with here. So we're dealing with lat-long. Okay. So when you're dealing with latitude and longitude, but your elevation is in meters, which is the case here, you're not going to get, because slope, for example, because elevation, right, that doesn't really matter because your elevation is what your elevation is. It doesn't really matter what your x and y is. But slope looks at the change in elevation over your xy, right? So what's happening is QGIS is expecting meters, but it's getting degrees. And so remember, a degree is a different number of meters depending on where you are on the Earth. So we can add a scale factor to correct for that difference. So if we go to raster, analysis, slope, and ratio of vertical units to horizontal. So if we put in 111,120, right? And so right now we're looking at slope in degrees, and we run it with that correction factor. That'll correct for the fact that our x and y are in degrees while our elevation is in meters, and you end up with slopes ranging from 0 to 23 degrees or so, which that makes sense. That's with reality. So you can also, if you want to run this as as percent instead of degrees. Okay, so you've got 0 to 44% slope, which, yeah, it's about right. So that is why you were getting crazy slope values and how you can correct for that. Now, the more rigorous way to correct for that is if you actually change the coordinate, you actually warp your raster image. So with vector data, you can just change the coordinate system and they adjust. But since raster data actually has the coordinate reference system baked into the image itself, we need to warp the image onto a projected coordinate reference system. And we'll use UTM-16N because this is in Illinois here. So what we're going to do is go to raster, warp, projections, and warp. So we've got our raster image. Our original is WGS84. It was a geographic coordinate reference system. And we're going to go ahead and warp that onto UTM zone 16N. So we're going to run that now. Okay. And so when we ran that, so here's our old unwarped image here. So when we ran that, we warped it, right? We warped it to the UTM-16N. And so, we're still seeing lat-long values down here. So we want to make sure our project coordinate reference system is set. So let's look at our properties. And we want to make sure we've got our project set to UTM-16N. Okay. So we did actually, it changed the shape, right, it changed the shape of the raster because you did warp it, you projected it onto onto a flat surface. And so now notice these coordinates, these are UTM coordinates. Okay, so now we've got our raster warped and we've got our project coordinate reference system set as 16N, UTM 16N. So now if we go up to raster analysis, slope, so now we do not have to put a correction factor in here. Let's just run it. We're running on the root projected, which is correct. So let's run it. And here we got a slope between 0 and almost 30. So the correction factor wasn't exactly right, but it got us pretty close. But since now we're dealing with the warped image, now these are correct. And so let's also go to, we can just run it just as a check. Slope expressed as percent instead of degrees. Run that. And again, this was a little this difference is amplified here, so between 0 and 57 degrees. So the correction factor we put in got us within the ballpark, and you could mess with that correction factor if you really wanted to figure out what the exact correction factor is for your geographic area, because again, the number of meters that a degree measures changes anywhere you are on Earth. But my recommendation would be just to warp the raster so that you let QGIS go ahead and calculate these values for you. And so now our slope makes sense. Our slope numbers make sense, and everything is working out. So do remember, when you're working with raster data, you need to warp that raster data. You can't just change the coordinate reference system of the project. You do need to warp that raster data so that you can change that baked-in coordinate reference system that it has and actually project it onto a flat surface. Then you can go ahead and do calculations.